Welcome to aminacademy.com. In statistics and econometrics, let us discuss about covariance and correlation. In statistics and probability theory, covariance deals with the joint variability of two random variables, x and y. Generally, it is treated as a statistical tool used to define the relationship between two variables. In this article, we will discuss about covariance meaning, formula, and its relation with correlation are given. What is covariance? It is a measure of the relationship between two random variables and to what extent they change together. That means we have to get the relationship between two variables given. Or we can say, in other words, it defines the changes between the two variables such that change in one variable is equal to change in another variables. This is the property of a function of maintaining its form when the variables are linearly transformed. Covariance is measured in units, which are calculated by multiplying the units of two variables. Covariance can have both positive and negative values. Based on this, it has two types, positive covariance and negative covariance. In positive covariance, if the covariance for any two variables is positive, that means both the variables move in the same direction. Here, the variable show similar behavior, means once increase, other also increase. Otherwise, once decrease, other also decrease. That means if the values greater or lesser of one variable corresponds to the values of another variable, then they are said to be positive covariance. Negative covariance. If the covariance for any two variables is negative, that means both the variables move in the opposite directions. One move up, that means other moves down. It is the opposite case of positive covariance where greater values of one variable corresponds to lesser values of another variable and vice versa. Covariance formula. Covariance formula is a statistical formula used to evaluate the relationship between two variables. It is one of the statistical measurements to know the relationship between the variance between the two variables. Let us x and y are any two variables whose relationship has to be calculated. Thus, the covariance of these two variables is denoted by COV of x comma y. It means covariance of x and y. The formula is given below the both population covariance and sample covariance. For population covariance formula is covariance of x comma y is sigma xi minus x bar into yi minus y bar over n. For sample covariance is equal sigma xi minus x bar into yi minus y bar over n minus 1, where xi is the data value in x. So xi means x1, x2, x3 like. Yi means y1, y2, y3. It goes like. Yi is data values of y. X bar mean of x. Y bar is mean of y. N is number of data values. By using this formula, we can find the covariance of xy for the given data. Here, look at this graphically, that covariance of x and y. Here, covariance of x and y is greater than 0 means it looks like positively it's increased, and there is no covariance, that means covariance of x and y equals 0 means it is dotted like, not extend here and there. Then covariance of x and y is negative means it like. Covariance of positive is this, just opposite is this way. Covariance of x comma y is greater than 0, then we can say that the covariance for any two variable is positive and both the variables move in the same direction. Covariance of x comma y is less than 0, then we can say that the covariance of any two variables is negative and both the variables move in the opposite direction. If covariance of x and y is 0, then we can say that there is no relationship between two variables. That means if covariance is 0, there is no relation between two variables. Correlation coefficient formula. We have already discussed the covariance, which is the evaluation of changes between any two variables. Correlation estimates the depth of the relationship, how depth it is related between the variables. It is the estimated measure of covariance and is dimensionless. In other words, the correlation coefficient is a constant value always and does not have any units. The relationship between the correlation coefficient and variance is given by correlation, that is rho of x comma y is covariance of x comma y into sigma x and sigma y, where rho of xy is correlation between two variables x and y, covariance of xy is covariance between the two variables x and y, sigma x is standard deviation of the x variables, the sigma y is the standard deviation of y variables. That means correlation coefficient rho of x comma y is covariance of x comma y divided by sigma x into sigma y. Based on this value of correlation coefficient, we can estimate the type of correlation between the two given two variables. Also, the graphical representation of correlation amongst two variables is given in the below figure. Here, it is a strongly positive correlation. Suppose the dotted given. If we join most easily, that means most nearer to all points is gives a straight line. It's a strong positive correlation. It is a weak positive correlation. This is slope is more, the slope is less. Weak positive correlation, that means dispersing points are more away from the line joining best fit line. Here strong negative correlation. This is the points are very near to best fit line, as well it is a negative correlation. Here weak negative correlation, some points are outer than best fit line. It's a moderate negative correlation. It's a somewhat moderate. It is a here no correlation because we cannot estimate the best fit line considering all points. So here no correlated. The points are not in correlation. Covariance and correlation. We can see in the table the difference between covariance and correlation. In covariance left side, correlation is right side. It is a given, it's a measure of show that extent to which given two random variables change with respect to each other. It's a covariance. Correlation is, it is a measure of used to describe how strongly the given two random variables are related to each other. Random variable related to each other is the correlation. Covariance, it is a measure of a correlation. Correlation, it is defined as the scaled form of covariance. Covariance is a measure of correlation. Correlation is defined as the scaled form of covariance. The value of covariance lies between minus negative to positive, minus infinity to positive infinity. Those much values are possible in covariance, and the value of correlation lies between minus negative to positive 1, minus 1 to positive 1. In between, the correlation is there. Covariance, it indicates the direction of the linear relationship between the two variables. It shows the direction. So positive means positive direction, negative correlation means negative direction. It measures the direction and strength of the linear relationship. It measures the direction as well as the strength of the linear correlations between the two given variables. Covariance and variance. Covariance and variance. Covariance and variance both are the terms used in statistics. Variance is the measure of spread of data around its mean value, but covariance measures the relationship between two random variables. Here, Variance is relation between the random variables, two random variables. Covariance and used in statistics. Variance is the measure of spread of data around its mean value, but covariance measures the relationship between two random variables. This is the difference between covariance and variance. Some example, covariance example will do. Below, look at this example. Calculate the coefficient of covariance for the following data. X data is given, Y data is given. You have to find the how it is related as a covariance. So here number of items are 6. So the observation is 6. So n equal to 6. Mean, you have to find the mean of this one. Add them and divide by 6. It gives 17.67. Mean of y is add y values and divide by 6. It gives mean. Now use that mean is xi. This y mean is yi. So covariance formula is, we know that covariance formula is given like this formula to use. Covariance is covariance of x comma y is sigma xi minus x bar into yi minus y bar over n. So use that formula. For that, look at here. 1 over n, that is 1 over 6 into 2, x value is 2 first, 2 minus x1, y is 5 minus x1 is 5, y1 is 5, y1 minus y bar, like plus x2 minus x bar, y2 minus y bar, and x3 minus x bar, y3 minus x bar. Like that, you have to put the points and simplify. We get the covariance is 157.83 is the covariance of x comma y. Covariance matrix. In statistics and probability theory, a covariance square matrix provides the covariance between each pair of components or elements of a given random vector is called the covariance matrix. Any covariance matrix is symmetric and positive semi-definite. The principal diagonal or main diagonal, sometimes a primary diagonal, of this matrix contains variances. That means the covariance of each element with itself. A covariance matrix is also known as the autocovariance matrix, variance matrix, dispersion matrix, or variance covariance matrix. So far we have done about covariance and variance and about correlation we discussed. We have done. Please subscribe our YouTube channel.